Decades after the Apollo and Luna programs, when humanity's focus had shifted toward other planets, the Moon quietly held on to its secrets. The last Soviet sample returned in 1976 had seemed to mark the end of an era. But almost overnight, the lunar race began again. SpaceX rockets thundered into the skies. NASA introduced its ambitious Artemis program, and China made quiet but steady moves into regions no nation had dared explore before. Soon, whispers emerged about peculiar discoveries on the mysterious far side of the Moon. What was hidden beneath its dusty surface, and why was the world suddenly returning? To understand this resurgence, we need some context. China's lunar exploration is surprisingly recent, beginning in the early 2000s. Following a carefully designed step-by-step plan, the China National Space Administration, named after the moon goddess Chang'e, launched a series of orbiters and landers to study our closest celestial neighbor. Their goal: combine science with strategy, advancing knowledge while elevating China as a global space power. In 2007, Chang'e became China's first lunar orbiter. It created a three-dimensional map of the Moon and analyzed its soil composition. Among its most intriguing results was the detection of helium-3 within the lunar regolithon, early clue that hinted at China's long-term interest in space resources. By 2010, Chang'e had launched with higher-resolution cameras. It scouted possible landing sites by flying just 14 kilometers above the surface, photographing terrain to assess safety. Only 3 years later, China achieved its first soft landing on the Moon since 1976. The lander touched down in Mare Imbrium and deployed the U-21 rover, marking the end of a long silence in lunar exploration. That rover carried a unique ultraviolet telescope, the first of its kind to observe from the lunar surface. But the real breakthrough came in 2019, when Chang'e was sent to explore the Moon's far side, a place no spacecraft had ever landed before. Originally built as a backup for Chang'e 3, it was redesigned to attempt this bold mission. Landing on the far side posed enormous technical challenges. Because the Moon always keeps the same face toward Earth, direct communication with the hidden hemisphere is impossible. China solved this by launching a special relay satellite, Qiqiao, the Magpie Bridge, positioned at the Earth L2 point. From there, it maintained constant line of sight with both Earth and the far side. On January 3, 2019, Chang'e descended into the Von Karman crater, part of the immense South Palakan Basin, one of the largest impact structures in the solar system. Shortly after landing, the U-22 rover rolled onto the gray dust. For the first time in history, humanity was exploring the lunar far side. The landscape was unlike anything seen on the near side. Instead of vast dark seas of lava, the far side revealed a thicker crust, heavily cratered and ancient. Scientists hoped this mission would help answer one of the Moon's biggest mysteries. Why are its two faces so dramatically different? The rover's discoveries soon drew attention. In mid-2019, operators spotted a shiny, unusual patch inside a small crater. This mysterious gel-like substance fueled speculation worldwide. When images were finally released, scientists determined it was impact-melted rock, glassy breccia formed by a meteor strike. Not alien slime, but still a remarkable find, telling the story of violent collisions that shaped the Moon. Yet not all of Chang'e's experiments were geological. It carried a small sealed biosphere containing soil, seeds, and insect eggs. In January 2019, scientists announced a historic achievement. For the first time in history, a plant had sprouted on another world. A cottonseed produced a delicate green shoot under lunar gravity, though it withered within days when lunar night froze the container. It symbolized a future where astronauts might one day grow food on the Moon. These milestones caught the attention of scientists worldwide and also fueled conspiracy theories. Some speculated about alien structures hidden on the far side after U-22 photographed a cube-shaped silhouette on the horizon. Dubbed the Mystery Hut, it sparked weeks of internet frenzy, until the rover got closer and revealed it was simply an oddly shaped rock resembling a crouching rabbit. But beyond sensational rumors, Chang'e highlighted China's methodical approach. The far side is more than a scientific frontier. It is also a potential strategic outpost. Shielded from Earth's radio noise, it offers a pristine environment for telescopes. It may also conceal valuable resources, such as water, ice, and permanently shadowed craters and helium-3 trapped in the regolith. Helium-3, in particular, is often described as the gold of the Moon, rare on Earth but abundant on the lunar surface. This isotope could theoretically power nuclear fusion reactors, providing vast amounts of clean energy. Estimates suggest there could be over 1 million tons on the Moon, enough to fuel Earth for thousands of years. Extracting it remains a distant dream, but nations know whoever masters it will gain a strategic advantage. China has not hidden this ambition. Its orbiters have been mapping helium-3 distribution since the beginning. And in 2020, Chang'e returned lunar samples containing traces of helium-3 and even a new mineral, Chang'e. These findings only strengthened the case for lunar resource exploration. At the same time, evidence for water ice at the poles has become undeniable. Permanently shadowed craters, where sunlight never reaches, appear to trap frozen reserves. For future astronauts, water means more than drinking it, can be split into hydrogen and oxygen, serving as rocket fuel. China has announced upcoming missions to probe these polar deposits directly. All of this points to a larger vision. The Chinese roadmap includes building a robotic research station on the far side by the 2030s, potentially using 3D printing with lunar soil. In partnership with Russia and other nations, they propose an International Lunar Research Station, ILRS, while the United States pursues its Artemis program. Supported by private companies like SpaceX and Blue Origin, the stage is set for a new space race not just about flags and footprints, but about resources, infrastructure, and long-term presence. Both Artemis and ILRS target the same region near the lunar South Pole, rich in ice and sunlight. This overlap could lead to collaboration or competition. Already, samples brought back by Chang'e 5 and Chang'e 6 are being analyzed for clues about the moon's past. Meanwhile, Chang'e 7 and Chang'e will scout for water and test technologies for using local materials, laying the groundwork for permanent bases. On the American side, Artemis aims to return astronauts by the late 2020s, eventually establishing a sustainable presence. The big question remains: who owns the moon's resources? The 1967 Outer Space Treaty prohibits nations from claiming territory, but leaves the issue of resource extraction vague, as multiple powers prepared to mine the moon. New agreements or conflicts may emerge. One thing is clear: the moon has re-emerged as the central arena of 21st century space exploration. Unlike the Cold War race of the 1960s, today's competition is about securing the future. Will these discoveries lead to international cooperation, or spark rivalries over the treasures of our nearest neighbor? For now, the far side is no longer hidden in darkness. It has become the testing ground for a new era where the moon is not just a symbol of human achievement, but a frontier that may determine the fate of our civilization.